So this is the supplemental instruction about the different types of encryption types to go along with the presentation for CIT 120 security threats and countermeasures of Windows 10. So we're going to talk about three different types of encryptions: basic encryption, synchronous encryption, asynchronous encryption, or hash. So let's get started right away. All right. So again, at the core, we're going to have the concept of encrypting. We're going to have plain text. All right. I'll just call it PT. All right. And then we're going to have cipher text. Right. The cipher text is text that's been encrypted. Right. So we're going to have the plain text go into a process and come out cipher text. Usually that process is an algorithm, a mathematical algorithm, especially in the world of computers, because, well, computers see the whole world as math, ones and zeros, so we might as well use math to encrypt it, right? Again, what we're going to do is we're going to have this variable put in called the key sometimes, all right? Sometimes the key is thrown in here, right? Because essentially what we can do is use the key to throw a variable into the conversation. All right. So now, in the case of synchronous encryption, we're going to use the same key to encrypt and decrypt. All right. A good example of this would be if you did like a ROT13. So let me get rid of that and bring in a web page here. Here's my drive, and let's do an example of a ROT13 rotation. By the way, is rotation 13 cipher. Okay, there we go. I guess we're just going to use a simple Java script, right? Well, the ROT13 is going to do is it's just going to rotate the characters 13 spaces, right? So A becomes an N, B becomes a O, LMN, O, right? C will become a P, D will be a Q, so forth and so on, right? So if I sit there and I write anything that's encoded, you know, we'll put a joke in there. There you go, ha ha ha. It's going to turn into WB XR. Here, I'll zoom in on that so you can see, right? So a joke, I put it in, it becomes WBXR. All right. So anyway, so in that case, we're using the same key over and over again. In that case, it's just using the mathematical formula, moving it over 13 spaces, right? If we have another, let me bring up CyberChef, and I'll show this. So CyberChef is a program. That's a good joke. Anyway, so I saw the mining Bitcoin hash. So all right. So let's do a synchronous code. We could do a vignette. You know, that's a good example. Why don't we do all right, we'll do one of these encodings, right? So what will happen, it's going to use this key to encode it, right? So in other words, I would need this key. In this case, let's just call it a super key, right? So when I use that key, I'm going to take some kind of information, we'll call it plain text, and then we're going to get an output, right? Now I can't decode that until I know what it is. So if I grab this output, and I'm going to close this now, all right, and I'm going to bring in a decode. I'll throw this in the trash, all right? So now I have a decode. The input is going to be V, okay? And until I put in what that code, so if I put in the wrong one, like we'll put help, right? I'm going to get garbage output out, right? Because essentially that variable has changed, okay? So I'm going to use the same key, a super key, if I remember correctly, hopefully. There you go. And I got my output of plain text. Okay, so that's essentially what we're talking about, all right? We're going to use the same key to encrypt and decrypt. Now, the beautiful thing about that is it's fast, all right? The downside to it, it's somewhat pretty good at cracking, or it's easier crack. It's easier to crack than it is asynchronous, okay? Matter of fact, if we transmitted all our credit card numbers and personal data with synchronous encryption, it would be a lot easier to hack that, right? The entire process. So there's another system called asynchronous. Now, so by the way, the 2 penny, what you need to remember for the test is synchronous. I use the same key to encrypt and decrypt data. Okay. Now, asynchronous is going to use what we call a key pair. All right. Now, we see this the most on the internet, but it's a very good way to encrypt data, and also we can use it to authenticate users as well. This is drawing pretty fast. I should probably keep my mouth quiet. But all right. So what we're going to do is we're going to have a public key. All right. So there's a public key. We're going to have a private key, PRV, right, on both ends. All right. So usually this key, especially when we're talking about a public server, so this is some kind of web server out here. Let's just say Amazon. I'm trying to buy dog food or whatever else. So normally I'm going to have this situation where I have a public key and a private key. This key or this key pair is going to be issued to me as a certificate, right? And we don't have time to get into the whole certificate authority infrastructure, but this is going to issue to me. That way I know I can trust it, right? It's not, I know it's been issued by a respectable company, and therefore this is a respectable company. But essentially any asynchronous encryption, including if it's not issued out by, I generate my own certificate or I generate my own key pair. What happens is if I want to send you data, right, what I can do is I can grab your public, right, and my private and make what we call a key pair. All right. Now this key pair is going to be used just like the key. It's going to be thrown into this encryption, this algorithm, right, and it's going to be able to take the plain text and create cipher text. Okay. That's all it does. Now when I send the data along, you can't get my private key. You never give out your private key. Or never give out your private key. Never give out your private key. It's very important. Okay. But what you do is you use your public. So in this case, I'm going to create my public, excuse me. So what this web server to do to decrypt it is going to have to form its own key pair. And the way it does is it takes its private and my public and creates a key pair of that, right? So it takes these two, makes its own key pair, and that same key pair can be used to decrypt that data and take that clear text, reverse through it, and get plain text. Okay, so asynchronous, you're going to use different keys because even though, and by the way, when I do that, the keys would actually look different. Okay, they're rather large. If you look at SSL, you look at certificates, they're going to be very large keys, but there'll be different data. This key pair would be a different value than this key pair. Okay, so you're actually using two different keys to encrypt and decrypt. Okay. How that actually works, I can't tell you. I know it was developed in Berkeley back in the I think late 70s, early 80s. Anyway, so the point is, it's high level math, but you're using two different types of keys to a different key to encrypt and one key to encrypt and a different key to decrypt. Is probably the easier way to say it. Okay, so you're using two different types of keys. So synchronous using the same key to encrypt and decrypt, asynchronous using different keys to encrypt and decrypt. And then finally we have hash. Hash does not use a key. What it does is it uses a very complex algorithm that includes multiple passes, lots of multiple passes, breaking it down into smaller bits and multiple passes to encrypt the data. All right. So again, you're going to end up with clear text, right? And then you're going to end up, you're going to start off with plain text, and you're going to end up with cipher text. Okay? That's what a hash does. Now, this clear text is not going to be, it's a one-way street. With a hash, it's a one-way street. That's the one to remember. It's a one-time encryption. I'll give you a little example of it, too. So let's go to CyberChef again. Oop, I have to get out of full screen mode. I actually have to get out of draw mode, and then I have to get out of screen. There we go. So let's start all over and let's grab some crazy input. Let's go to Stick's website and grab, typo. Let's go to Stick's website, and we're going to grab a little bit of plain text. Let's grab our about Stick. Let's grab our, well, let's pick on the president, shall we? So there we go. We're going to grab his data here. Okay. Now this is the beauty of hash, and this is why we use it to do a couple of we can do it for use it for a couple of normal things. So if I take an input, I grab all this. Obviously, I'm going to get the same output because we haven't done anything of it. If I go down here and I grab hashing, let's grab a basic one. MD5 is a highly used hash. Now here's the beauty of it. I got all this data and it gives me that output. Now watch what happens. If I just use an A, I'm going to get output, right? If I put a B, it's going to be the same size output, okay? Now this hash is not created, and you can't mathematically get back your output. You take output and get the input. It's a one-time hash. The whole point of this is a one-way encryption, okay? Now it has also another important thing too. If I do Control A, I put back our president's message, and I just change one little thing. Like say I change this one little period right here. So I'm going to change this period. Keep your eye on the output. If I just change that one little period right now, everything changes. It's a massive difference. Okay, so it's primarily, most of the time, hash is used for making sure data got sent, right? You have your cat video. If I want to make sure one station sends a cat video to another station, the second station can verify they got sent by looking at the hash that came along with it, and no matter how big the file is, if there's just one little change, again, that little period, if there's one little change, then I will see a different hash value come out. All right, that's one advantage. The other thing I can do with it too is store passwords, right? So even if I have a crappy password 123, I'm going to get the same output as if I had super capital DUPER exclamation point underscore pass and then pound word, right? Really hard to remember. Oh, we got to put numbers in there too. 5355555. Right. Point is, even if I have all the, it's still the same output, right? So in a way, it's strengthening it. Now, what you can do, just FYI, is create rainbow tables. So like MD5 is used in older operating systems as your hash. It's not used anymore, but some older operating systems still use it. So if I wanted to know what password 123 looked like as a hash, only password 123 will come out with this hash, right? It's fairly unique, okay? There's not a lot of collisions, as they're called, or duplicity, right? You're not going to get multiple outputs or the same output for multiple inputs, all right? So the point is, if I get someone's hash, if I'm able to sit there and say, okay, here's the hash, let me try hashing it with MD5, and I get the same output, and then I know their password is 123. Okay, but that's what your operating system does. When it stores the password, it's going to store it as a hash. All right, and that's where it comes in important to Windows. All right, so a hash is a one-way encryption. So there you go. So in summary, all that talking, and I can summarize it very quickly by simply saying synchronous encryption uses the same key to encrypt and decrypt. Asynchronous uses a different key to encrypt, asynchronous uses different keys to encrypt and decrypt, and hash is a one-way encryption. All right. I hope that helps. Talk to you later.